So now let's take what we've learned about urban structure and think a little bit more about how travel patterns might either be enforced by that structure or might actually affect how that structure develops over time. So, in our most basic conceptualization of the city, we thought about this highly clustered, highly centralized place. And, maybe we would expect most of the travel patterns going from the outside areas to just be going, toward that central place in a radial way. And certainly we see this happening in a fair amount of urban landscapes. Even if you look at San Francisco, which is a fairly complex and polycentric urban area, you still see a lot of traffic that's directed sort of radially toward major central places like downtown San Francisco and San Jose, etc. And that's how a lot of the infrastructure seems to be built. BART trains go into the downtown areas, and highways and bridges tend to go into the downtown areas. That said, even within a fairly monocentric urban organization, there is necessarily traffic that ends up flowing, between outside areas. So not necessarily radially into the downtown, perhaps, but between suburbs, between hinterlands, there is necessarily going to be some amount of flow. And so it's important for transportation planners to think about how that flow might be accommodated without having to go, for example, all the way into the center and then back out again. As we get into places that have more polycentric forms with centers that are distributed around an urban landscape, those flows that are between peripheral centers are going to become even greater. And so planning for those flows and developing infrastructure that not only goes from outlying areas into the center, but also goes between outlying areas becomes increasingly important. And we'll see in just a little bit how different modes might accommodate some of these flows in more or less efficient ways. One of the things that is, in some senses, really efficient about car travel is that it allows for a lot of flexibility in terms of how people travel within an urban region. Again, assuming that the infrastructure is there to support it. But with a widely dispersed roadway network, you can actually get a fair amount of disorganized travel between outlying places to accommodate different needs that people may have. Whereas with something like a transit network, in order to accommodate all those secondary flows, between outlying places, you need a fairly organized structure still, because transit can only travel on the routes that it establishes. And so different modes accommodate these more organized or disorganized flows between monocentric or polycentric places more or less effectively. One way that we can think about how different modes might accommodate different types of flows is to think about the commuter sheds that are produced by different modes or have been produced by different modes through different eras of development. We're going to get more into the history of urban development and what has prompted these transitions between different transportation technologies in the next module. But for now, let's think about what are the practical constraints in terms of using different technologies to commute from different parts of the city. And to keep things easy, let's talk about commuting just to the central city. So if you are walking, you have a fair amount of flexibility in where you're coming from in terms of which direction you're coming from. You could start at really any place within this circle and commute to the central city, because walking is very flexible in terms of the routes that you take, assuming that there's a fairly distributed street network on which you can walk. That said, you can't go very far by walking, and so the commute shed for walkers around a central place tends to be fairly small, but it tends to be fairly round. A streetcar, by contrast, you might end up seeing this sort of star shape, because accessibility to this central place is going to be greatest along the streetcar line. So let's imagine that there are streetcar lines along these dashes, it's fairly easy and quick to commute to the center point from somewhere along the dashes. But as you get farther away from the dashes, you would need to, walk to the streetcar line, which might take some time, and then take it in. And so there's very little access with the streetcar in some of these places between the points of the star. Technologies like cycling, again, there's a lot of autonomy in terms of the routes that you could take, assuming that the street network is there. And so, again, you might see a more circular form if that was the dominant form of transportation. And then an automobile is actually quite similar. There's a lot of freedom with where one travels with an automobile if the street network is there to support travel in all those different directions. And so, with an automobile, you could very easily, commute from, anywhere within this large circle. You could also easily move between places out on the periphery here. Whereas with a streetcar, if you wanted to get, between points of this star, you'd have to go all the way in and then back out. And then finally, thinking about an automobile, but with freeways. So freeways being a very special type of road where you can travel very fast, so high mobility, but less accessibility. You once again see this star shape emerging where there's less accessibility available between the points of the star because you have to travel along much slower, perhaps local roads, but you can travel really fast, along these corridors that the freeways are built on. And so what this demonstrates is that the shape of urban places can be really substantially influenced by the dominant transportation technology that is being used in those places. In fact, we see these shapes changing in time in terms of how development has built outward from historic cities that began as walking-oriented places and now might have rail or car or freeway-oriented transportation systems. Transportation systems have also developed to address some of these issues with lack of accessibility between corridors of major mobility, like freeways. So, for example, the ring road has been developed as a solution for providing access between secondary centers that are on outlying areas that you might want to get between without having to go through a city center. You see ring roads really clearly in cities like Washington, D.C., which has the Beltway, Boston, which has 495, and even within the San Francisco area, we see effectively ring roads that go all the way around the bay, connecting places like Oakland and San Jose without having to go through San Francisco. And a ring road really effectively demonstrates how increasing connectivity between places increases accessibility. So in this diagram up top here, you can see the numbers representing the amount of time that it might take to travel between these different points. So the links that are further toward the city center take more time because they're more congested. And so let's say that we want to travel between this point B and this one up here. Before we install the ring road, it might take us 20 minutes to travel all the way into the city center and then back out. But a ring road might connect those 2 points in just 10 minutes. It's a shorter distance, but we also avoid all of that congestion in the central city. The ring road also, though, might make it easier to travel places, even traveling a longer distance, but just with less congestion. So if we install the ring road, it's going to take the same amount of time to travel on the ring road all the way around from B over to A as it would have to drive a shorter distance straight through the city. So as an effect, a fair amount of traffic may be diverted to actually travel a longer distance just to avoid this congested area. And then that may in turn even promote development out in these outlying areas because there'll be so much traffic that's going just on these outer areas without even going through the city. And so you might end up with these cyclical dynamics where traffic is diverting in order to avoid a congested place, but that in turn just shifts the congestion to a different part of the transportation network. And then a lot of places, actually, there's now more activity going on in peripheral landscapes and sometimes even more congestion. Again, Washington, D.C.'s Beltline is a good example. It's incredibly congested, despite the fact that it's on the outskirts of the city.